In this lesson, we're going to be taking our understanding of proportions and taking it a step further and looking at applications and real-world examples where proportions come into play. This first example is a proportions real-world problem discussing the concept of unit conversions. Look at the unit conversion that we're given. We're given that 1 ounce is equal to 28.35 grams. So those two weights, we'll call them, are going to be equal to one another. What we want to do is we want to convert 365 grams into ounces. We want to know how many ounces are in 365 grams of whatever you're trying to weigh. So here's how we're going to set it up. You can see that I have a 3-step process. My first step is going to be writing a word ratio. A word ratio is basically what am I comparing? So in our case, we're going to be comparing ounces to grams. So usually you can get that right in your conversion statement up above, and you can just pop that right into your word ratio. All right, the next thing we're going to do is we're going to set up a proportion. By setting up a proportion, I'm going to start by just kind of drawing my ratio line, my equal sign, and then another ratio line. Now, the first ratio that I'm going to get is going to be right at the beginning, right? That information that is given to me right at the beginning. So that's going to be 1 ounce to 28.35 grams. So 1 ounce to 28.35 grams. So that is what was given to me. In the other ratio, what I want to do is I want to take the other information that I'm given. In our case, it says convert 365 grams into ounces. You can see that they give me the information 365 grams. So on the bottom here, I have grams. So I'm going to go ahead and put 365 along the bottom to match up with my word ratio. On the top, it's asking us, well, we want to convert that into ounces. So we basically are trying to figure out how many ounces. So therefore, we have a nice proportion all set up for us. The third step is to solve the proportion. So let's go ahead and do that. This is from the last section. If you remember correctly, we want to go ahead and circle our cross products, and we want to multiply them. So I'm going to say 28.35 times x is equal to 365 times 1. Which, of course, that's going to simplify down to 28.35x is equal to 365. I just multiplied it by 1. If you remember, we're trying to solve for our variable x, so I'm going to go ahead and divide both sides by that 28.35. And I'm going to go ahead and just use my calculator to calculate 365 divided by 35. To give me x is equal to about 12.87. Now, it's not just 12.87. We actually have to have a label on this. So if you go back up and you take a look at, let me change my pen color. If you take a look at the x is in the numerator. You can see that the numerator corresponds to the numerator ounce in our word ratio. So that's how we're going to get our label on our answer. So I'm going to go ahead and label him ounce or ounces. And that is our answer. All right, here's another application of these proportions. It's called a scale drawing or model. So sometimes you might have a like a model car or a model boat, and it'll be significantly smaller than the actual size of a car or a ship. And what we want to do is figure out, well, what is the conversion between the two? So let's take a look at this example. A car model is being built with a scale of 2 inches to 5 feet. Now, what that means is for every 2 inches on the model car, that represents 5 feet on the actual car. So continuing on, the actual length of the car is 12 feet. What is the length of the model car? So The first thing we want to do here is set up a word ratio. And this one's a little bit trickier because we want to figure out, like, what are we talking about? It looks like we're talking about model cars, right? The car model, and then the actual. So let's go ahead and figure this out. Let's go ahead and put the model on the top. So this is our model car. And we're going to say that the model car is in inches, right? Doesn't that seem reasonable? And we're going to divide that by the actual car. And again, we're talking about the length, so we're going to end up working with feet here for the actual car. Now we're going to go ahead and set up our proportion. Again, we get the information right from the problem. So in our problem here, you have 2 inches to 5 feet. See this right here? This is called a scale. They give us the information that is actually the ratio that we want to put in first. So here's our first ratio, 2 inches to 5 feet. Now we need to figure out the other piece. Let's read that second sentence again. The actual length of the car is 12 feet. So you can see that I put actual car on the bottom of my proportion. So I'm going to go ahead and put a 12 at the bottom of my proportion. What is the length of the model car? Well, the model is in the top, so we don't know what the length is, so I'm going to place an X there. So let's go ahead and solve this proportion now. I'm going to go ahead and use my cross products, and I'm going to multiply them out. 5 times X is equal to 2 times 20. I'm sorry, not 2 times 24. I was getting ahead of myself there. 2 times 12, which you can see why I was getting ahead there. 5x is equal to 24. Now, we want to go ahead and solve for that variable x, so I'm going to divide both sides by 5. So let's see, 24 divided by 5 is going to give me x is equal to 4.8. Now, we need a label here. So 4.8. Let's go ahead and look back where our x is located. Our x happens to be located in the numerator, which corresponds to the model car. The model car is going to be in inches. So I'm going to say that my model car is going to be 4.8 inches. And that would be my label. So those are 2 good applications of proportions. I got a couple more here for you. Let's just take a look at this regular proportion. We're going to be comparing these 2 objects here. Josephina sells helium balloons. She charges $9 for 12 balloons. At this rate, what will Josephina charge for 50 balloons? So the first thing we want to do is create a word ratio. We want to figure out what are we comparing, what 2 variables. And the things that we're comparing are going to be money over balloons. All right, we're going to go ahead and set up our proportion now. The first proportion is the number that is given to us. You can see in the second sentence, it says she charges $9 for 12 balloons. That right there is your first ratio, $9 for every 12 balloons. And so at this rate, what will Josephina charge for 50 balloons? You can see that 50 balloons has a little label next to it, balloons. So I'm going to go ahead and put 50 in my denominator. And we want to know, at this rate, what is she going to charge? So there's going to be the placement of my x. Now the x isn't always going to be in the same position. It just happens to be in these last 3 examples. Let's go ahead and solve using our cross products now. We have 12x is equal to 9 times 50. All right, so 12x is going to be equal to 450. And I'm going to go ahead and try to figure out what my x is. So I'm going to divide both sides by 12. Remember, I'm trying to solve for that variable. So my x is going to equal 37.5. Now, let's think about what we're trying to answer here. If you go back and look at your x is in the top, which is stating that we're talking about money. So I don't want to say 37.5. I want to say this in money. So 37 point, how about 50 cents with a money sign? That sounds much better. So basically that's saying for 50 balloons, you're going to be charged $37.50. All right, this is a really great time to pause the video and try another problem on your own. Okay, on the map, 5 inches represents 100 miles. how many inches would there be between two cities that are 2,500 miles apart? All right, what two things are we comparing here? It looks like, right off the bat, inches and miles. So let's go ahead and set that up. I'm going to put inches on the top and miles on the bottom. And what's really cool about this is it does not matter whether you put inches or miles in the top or the bottom. As long as you stay consistent and create your proportions that are relatable to the word ratio that you've created. So I'll show you what I mean now. Let's go ahead and set up the proportion. You can see in that very first sentence, it states on the map, 5 inches represents 100 miles. So I'm going to put 5 inches in the numerator and 100 miles in the denominator. Now, if you had flipped the word ratio over to make it miles over inches, then your ratio would be 100 over 5. But we didn't do that here, so I'm just going to leave it as is. Now, let's go ahead and continue. How many inches would there be between two cities that are 2,500 miles apart? You can see that we're going to go ahead and place our 2,500 in our denominator, and we're going to go ahead and put our x in our numerator. And we're going to go ahead and solve our proportion by setting up our cross products. So I have 100x is equal to 5 times 2,500. Okay, now let's go ahead and simplify it. 100x is equal to 12,500. I'm going to go ahead and solve for my variable by dividing both sides by 100. And if I do that, it's going to simply give me x is equal to 125. Now, 125 what? If we look at where the x is located, you can see that he's standing across from the inches, which is going to be 125 inches as my answer. Okay, so we've done 4 really good application problems. Now I'm going to show you a different concept that has the same related idea. This is called a ratio table. So let's look at this example here. A recipe for oatmeal cookies calls for 2 cups of flour for every 3 cups of oatmeal. How much flour is needed for a larger batch of cookies that uses 9 cups of oatmeal? So this is called a ratio table that we have here at the bottom. So you can see that in our table we have some values, and then we have a missing value. That's the missing value that we're looking for, and that's actually what the question is asking in our problem. So to solve this, here's what we want to do. Let's take a look at the information that they gave us. They gave us that 2 cups of flour goes for every 3 cups of oatmeal. Do you see how that ratio actually shows up in our ratio table, 2 to 3? Well, that's actually going to be our first ratio. So let me show you. Let's go ahead and set up our word ratio. Flour to oatmeal. My first ratio in my proportion is going to be 2 over 3. And I'm going to go ahead and set that equal to the ratio that I'm trying to figure out. I'm trying to figure out how many cups of flour are going to be in 9 cups of oatmeal. So I'm going to put oatmeal on the bottom, and I'm going to put an X right there. Now, let's go ahead and do our cross products. So I have 3x is equal to 2 times 9. I'm going to simplify that down to 3x is equal to 18. And I'm going to go ahead and divide it. You're probably getting real quick at this point. So x is going to equal 6. 6 what? Well, if you look at the x, you can see that it corresponds to flour. So 6 cups of flour. Okay, now that is one way to do it. Now, the other really cool thing is this. We could have set up our proportion a little bit differently. And the reason is we have this ratio that we did not take into account. So we could have set 4/6. Instead of using our 2/3, we also could have done this. We could have put a 4 here and a 6 here and solved this problem exactly the same. And it would have worked out to give us 6 cups of flour. I'm going to show you that a little bit closer in the next example. So it says, how much will 5 pounds of gummy bears cost at the candy store? Well, you can see by our ratio table here that they don't give us any information like they did in the last one. They don't give us the ratio other than in the ratio table. So you can see that they give us that 3 pounds of gummy bears is equal to $12. And they also give us that 7 pounds of gummy bears is equal to $28. What we're trying to figure out is this guy in the middle. How much is 5 pounds going to cost? So here's a way that you can set this up. Let's go ahead and start with our word ratio. I'm just going to say gummy bears is going to be in the top. And then my cost is going to be in the bottom. Now, to set up my ratio, now this is kind of going back to that what I was talking about earlier. We can either pick either of these two that I'm putting a star around. You can pick either one of these ratios to place in the first ratio in your proportion. So I could put 3/12 or 7/28 in that place. I'm going to go ahead and I'm going to put 3/12. And then I'm going to go ahead and take the one that has the missing value and I'm going to put it in the other one. So 5, and the missing value I'm going to go ahead and label as X. Now we have a proportion. Now, not to be confusing, you could have done this. So your proportion might look like this. 7/28 is equal to 5 over X. Either one of these is perfectly fine. I'm going to go ahead and work with the top one. Here are my cross products. I'm going to say 3x is equal to 5 times 12. And I'm just going to simply go ahead and solve that down. So 3x is equal to 60. And then I'm going to go ahead and finish it off by dividing both sides by 3. So x is equal to 20. All right, 20 what? You can see that the x, I know it's getting a little sloppy here, but the x is in the denominator, which corresponds to money. So this means $20 is my answer. And that's going to be what is going to replace the question mark. So that's just another way to look at ratios. Sometimes they're given to you in a this thing called a ratio table, but you're really essentially doing the same thing. All right, let's look at one more example. I know this video is a little bit longer than normal, but I wanted to make sure I give you enough examples to understand the content. It says, fill in the blanks in the given ratio table. Instant rice calls for 5 cups of water for every 2 cups of rice. So you can see that they give you the information, 5 cups of water and 2 cups of rice. And they actually show that ratio right here at the beginning of the ratio table. So I'm going to go ahead and start the problem. My rice and my water. So my first ratio is going to be 2/5 because that's what's given to me. Now I need to figure out, well, what is this going to be under the 4? Well, let's go ahead and figure it out. My 4 is going to represent my cups of rice, and I am trying to solve for my cups of water. So let's go ahead and do our cross products to figure that out. So here it's going to be 2x is equal to 5 times 4, and then 2x is equal to 20. Divide both sides by 2, x is equal to 10. So instead of a question mark, we can actually go ahead and fill that blank in, and we can actually put a 10 right there. Okay, let's go ahead and try another one. We're just going to continue this on. Our word ratio is still going to be rice over water. We know that we have the ratio 2/5 to work with, but now let's go ahead and work with this one. So that's going to give us 15 cups of water to how many cups of rice? So let's go ahead and solve our table. So we have 5x is equal to 2 times 15. Solve it out. Oh, I'm sorry. I went a step ahead. Here we go. So 5x is equal to 30. I'm going to divide both sides by 5. X is equal to 6. And then I have one more to do here. I'm going to go ahead and use that same original ratio, 2/5, and I'm going to set it equal to x over 25, and that's going to represent this third piece. I'm going to go ahead and do my cross products. So now I have 5x is equal to 2 times 25. 5x is equal to 50, and 50 divided by 5 is going to be 10. All right, excellent. So with this ratio table, you can also see that whenever we found these numbers, they actually jumped by a constant rate. You can see that 2 gets to 4 by adding 2. And then 4 gets to 6 by adding 2. And 6 gets to 10 by adding, we're adding 4 this time. Interesting. And at the bottom here, let's see what happens. 5 gets to 10 by adding 5 to it. 10 gets to 15 by adding 5 with it. And then 15 gets to 25 by adding 10 to it. So we had to kind of double those last ones. So you can also look at the table like that. It should work very nicely like that. But I would always stick with the proportions to help you. All right, that brings us to the end of our video on proportion applications.